Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a US high school physics competition problem. So we have a spherical cloud of dust that has a uniform mass density of rho and a radius of r, capital R. So satellite A with a negligible mass is orbiting the clouds at its edge or with a radius of capital R. And then satellite B is orbiting the same cloud just inside the cloud with a radius lowercase r. And then lowercase r is smaller than a capital R. So we want to know the relation between the VA and VB, and then the relation between the period of the satellite that is orbiting this spherical cloud of dust. So, we want to compare TA and TB. So let's look at the first case, the A case. So we know this is a spherical cloud of dust has a uniform density rho. So its total mass is m is 4/3 pi r cubic. That's the volume of this spherical cloud of dust. And then multiplied by its density rho. So the gravitational force between this dust and then the satellite A is Gm ma. Ma is the mass of the satellite A, and then the distance r squared. This force should be the same as the centrifugal force of the satellite A, which is ma VA square over R. So we can derive VA is Gm over R square root from this equation. So then we plug m into here. Eventually we will get VA is R, and then 4/3 pi rho G. And then the period of the satellite A that is orbiting this spherical cloud is TA is 2 pi r, where r is one circle over the VA. And then we plug VA here, so the final answer is 3 pi over rho G square root. So now let's calculate case B, or the case for satellite B. And in this question, we neglect any drag force from the dust toward the satellite B. So before we calculate, we know that anything inside a hollow sphere will feel zero gravitational force. So no matter at what location inside this spherical hollow sphere, the total gravitational force on the mass will be zero. So that this means outside this orbit, or any dust that is beyond the radius r will have a net force of zero toward satellite B. So only the dust inside this sphere with a radius r will have a gravitational force on satellite B. So we effectively ignore any dust that is beyond radius r. So any dust that is outside r will have a net zero force on satellite B. So for the dust with a radius of lowercase r, the mass is m prime 4/3 pi r cubic rho. And then the gravitational force from this the dust of a radius of small r is g m prime mb. mb is the mass of the satellite B. And then because the distance is lowercase r, so it's r squared. And again, this force should be equal to the centrifugal force of the satellite B. So it becomes mb vb squared over r. So we can get vb is g m prime over r square root. Eventually we calculate this to be lowercase r 4/3 pi rho g. And the orbiting period of the satellite B would be Tb is 2 pi lowercase r over Vb. So we plug Vb here and we get an answer of 3 pi over rho g square root. So we know that Ta is this, Tb is this. So we get Ta is same as Tb. And then let's look at the Va. So this constant is the same, 4/3 pi rho g, 4/3 pi rho g. But because r, capital R is larger than the small case r, so Va is larger than Vb. So this is the final answer. Thank you for viewing. If you like my video, please comment, like, and subscribe.